this is the work example on how to solve a inequality that involves a quadratic. Let me just say that I'm a little bit under the weather, so if my voice sounds weird or I'm drinking water, coughing, that's why. But I'm feeling pretty good, so I still want to make this video. So in the worksheet, I sort of outline a step-by-step method on how to solve a inequality. So let's just go through and follow all those steps, and I'll show you how it's done. So the first step I have listed is you want to move all terms to one side of the equation. Now, this is already done for us, but like for example, if we had something that looked like this, then the very first step we'd want to do is just subtract that 3 over, but we're already given an equation with everything to one side, so we don't have to worry about this right now. But the second step is to factor the quadratic, so hopefully we're pretty good at this by now, but let's just go through it really quickly. We want to find two numbers that multiply to -3, but that add to +2. And so the two numbers that will work for us are 3 and -1, right? Because 3 times -1 is -3, but 3 plus -1 is the same as 3 minus 1, and that's just +2. So I can write down these factors like so. And let me make this a little neater for the video's sake. So we write down the equation with our factors, and now let's really briefly treat this as if it was an equation, not an inequality. So let's write down what the zeros of these factors are, and these will be our points of interest when we make our sign diagram. So I know that x equals -3 and that x equals +1. Alright, so now let's go ahead and make a sign diagram. Just a warning, the method I use to do a sign diagram is a little bit special. If you find it confusing, you can go to my website where I have a dedicated worksheet for this sign diagram method. Link will be in the description. But because this is the first time that a sign diagram is showing up in a worksheet, I'm going to take a little bit more time to explain what's going on, just for those who might need it. So we're going to make our sign diagram by drawing a number line. It's a good first step. And we're going to write down our points of interest. So our points of interest were -3 and +1. Alright. Now, the question we want to ask ourselves is, what type of line is generated by our points of interest? So for example, let's take -3 to begin. -3 was found by solving x plus 3 equals 0. And that specific function, if we graphed it, would be a positive line that is negative if the value is less than -3, and is positive if the value is greater than -3. So what this means is we can kind of draw a line on our sign diagram that represents this fact. And we're going to draw, whoops, sort of moved my tablet around. We're going to draw a positive straight line that represents the idea that if we're less than -3, we're going to generate a negative value by x plus 3, but if we're greater than x plus 3, or sorry, if we're greater than -3, then this function x plus 3 gives us a positive value. And this will make more sense in just a minute, but let's do the other one. So we have x minus 1, and again, positive line. If I'm less than 1, I'm going to get a negative value. If I'm greater than 1, I get a positive value. And so we can again represent this by a straight line through the point, like so. Okay. Now what we can do is let's split our number line into 3 intervals, right? So we have the first interval, which is from -infinity to -3. And we have the second interval, which is from -3 to +1, and then the final interval will be from 1 to +infinity. Now, if we want to go through and actually analyze these intervals, what we can do is we can pick a sample point and sort of see what values it's going to hit, right? So I'm not even going to name what the point is, but let's say I picked a point right here. Well, if I start traveling downward, I can see that I make contact with the blue line, and I'm getting a negative value. Don't know what it is, but I know that it's negative. And this red line will actually continue forever in this direction. So if I kept moving downward, I'm going to catch part of that red line as well, right? And so what's going to happen is that I'm getting two negative values, and according to our original function, they're being multiplied. Don't know what the values are, but I do know that they're negative. And so I get unnamed negative value times unnamed negative value, that is not a parenthesis, unnamed negative value. And then when I multiply those together, well, a negative times a negative is a positive. So I don't know what this value is, but I know that it's positive for this entire interval. Let's look at the next interval. If I pick a point from here, well, we can see that if I go upward, I catch a point from the blue line, but it's positive this time. And if I move downward, I catch a point from this red line, which is negative. And again, we can write down those points of interest. So I get unnamed positive value for my blue line times unnamed negative value for my red line, and a positive times a negative, well, that stays negative. So I know that this whole middle interval is going to be negative. And then last but not least, let's do the last part. So I'm sort of running out of room here, but if we move up, we catch this red line, and you can't see it, but that blue line is going to extend forever. Just don't have enough room to show it. But way up off the graph, we're going to catch another positive value from the blue line. And so we know that here we have positive times positive equals positive. Okay. So this is all helpful. We know we have a positive, negative, positive interval, but we need to interpret this in the context of the actual question. So the original question is asking about this function, when is it greater than or equal to 0? Well, we already know what it's equal to 0. We wrote those values down right here. But what about when it's greater than 0? Well, that is just all the positive values. And our sign diagram tells us the interval where these positive values lie. So let's write down those intervals. We're going to write down the positive intervals, right? So starting from negative infinity, moving all the way to negative 3, we determine that that's a positive interval. Then can we be equal to negative 3? Well, yes, because we're greater than or equal to a 0, and negative 3 is a 0. So we can tack a bracket onto there. Now we want to skip all of the negative values in that middle interval, so we can use the union symbol to sort of join together two intervals. Then we start at negative 1. Can we be equal to negative 1? Or sorry, can we be equal to positive 1? Yes, positive 1 is a 0. So I start with a bracket to show that 1 is included, and then that interval travels all the way to positive infinity, like this. And so that's our final answer. So we've taken the quadratic, factored it, broke it down into our points of interest, made a sign diagram to tell us where the positive values were the negative values, and then we used the interpretation of that sign diagram to draw out an interval. And that's the general process for how you would solve a quadratic with an inequality. And later in the course, we will expand on this idea for solving larger polynomial functions in an inequality. But we'll get to that later. I encourage you to try the practice problems on the rest of the worksheet.